Welcome friends, you can take a clear look at the question and keep observing this question for some moments now as I describe you the situation. See, the dots, the points of intersection in that grid are positions. If any two points are adjacent, then those two positions belong to friends. If AI and AJ are friends, then they have to belong to adjacent positions. Suppose AI is at a position, then AI and AJ are friends if they are adjacent along a row or along a column. That is the only condition which describes friends. And that means for this point, this is a friend, for this point, this is a friend, for this point, this is a friend, and so on and so forth. So let us go for solving this question. In the world of advanced, there is a saying that if the question is too big, then it's not complicated and the solution is short. And let's see what we can do here. For a moment, for having understood the definition of friends, now let's look at this question. If Pi is the probability that a randomly chosen point has I many friends, when I varies from 0, 1, 2, 3 and 4, like see this. This particular point has how many friends? 1 and 2. But this point has how many friends? 1, 2 and 3. Likewise, any point in the middle has how many friends? 1, 2, 3 and 4. And like this. So let x be the random variable such that for I equal to 0, x equal to I is Pi. Let's begin with probability for x equal to 0. A person has 0 friends. Not possible. P of x equal to 1. I equal to 1. A person has one friend only in this situation. Not possible. 0. P of x equal to 2. A person has two friends. How many such persons exist out of the total persons? Only two friends. Say this. 1, 2. Say this. 1, 2. Say this. 1, 2. Say this. 1, 2. There are four persons. Out of how many? 49. 1, 2, 3, 4, 5, 6, 7. 7 cross 7, 49 grid points. And now, P of x equal to 3. Which are the points or persons which have 3 friends? Now observe this. These points have how many friends? 1, 2 and 3. So how many such points? 1, 2, 3, 4, 5. 5 on a side. There are 4 sides. 20. 20 by 49. And P of x equal to 4. That is, there are 4 friends. How many such points are there who have 4 friends? This person, let's say 1, 2, 3 and 4. How many such points are there in the interiors? Now see this. In the middle, 5 fours are 20 plus 4, 24 points gone. 25 by 49. This is the probability distribution of the friends, of the number of friends. Pi, the probability that a randomly chosen point has I many friends, I varying from 0 to 4. X is the random variable, then a value of Pi is this, then the value of 7e of x. Now dear, theoretically speaking, expectation of a variable is equal to mean of the variable is equal to summation of Pi xi. And therefore, your expectation value is going to be, simply speaking, 0 into 0, 0 into 1 plus 2 into 4 by 49 plus 3 into 20 by 49 plus 4 into 25 by 49. Therefore, expectation value will be equal to all upon 49. Let's take the summations. 8, 60, 100. That means E of x value is equal to 168 by 49. Let's see if this is reducible by 7. So, if this is 7, 7 2s are 14. 28, 7 4s are 28. Therefore, 7 times E of x. 7 times E of x is equal to simply 24. This is the answer to the first question. This is 7 e of x. Now two distinct points are chosen randomly out of the points 49 given points. Any two points are chosen. Let p be the probability that they are friends. Then the value of 7p is equal to how much? The second question. Let's come to the second question solution. In this, the two randomly selected points have to be friends. Now, in how many ways can we select such friends? P. The second question solution. Solution to the second question. If the P is the probability that they are friends, how many such points can be selected? Now see this. Suppose I select one such point. Then the second point selection can be this, or this. Any one out of these four, hence 4C1. And how many such points exist? How many such points exist? These 25. Out of them take any one. Each time you get a 4 set of friends, you can select any one. This is about the middle points. Let's take one such point. How many such points are there? 20. 1, 2, 3, 4, 5 into 4 sides. 20C1. Each time how many friends are you going to get? 3C1. Or you take the corner points, the vertices. How many such are there? 4. You take any one. Each time how many friends are you going to get? 2C1. Now see this. This is a selection of 2 points out of given set of points such that each 2 of them are friends. Now, for the probability consideration, the denominator has to be a sample space counting of 49C2, any 2 out of 49 point selection, and that's it. This is the value of P. Let's calculate this. This is 100, this is a 60, this is a 8 upon 49, 48 by 2 factorial, 47 factorial cancels. That makes it 168 by 49 into 24. Now this is equal to, therefore P is equal to, after reduction, 7 7s are 7 2s are 14, 28, 24, 24 cancels, and that makes it how much? 1 by 7. 1 by 7. Now here we have, till so far we have achieved fairly good an answer. But let me tell you, here is the twist. And here is the breakthrough of this question, which if you cannot see, you are surely not going to make this question for full marks. Look at this. Look at this. You selected this point. Oh yes. And you selected any one of the friends. Oh yes. Now, any two pairs, let's assume these two pairs. This pair of points was selected in this how many times? I repeat, 25C1, let's say here. 4C1, let's say here. Now you have these 2 points as friends. In this counting, how many times did you select this pair? How many times did you select this pair? The answer is 2 times, because 25C1 carries this as well as 21C1 carries this, and each time you selected it twice. Similarly, this and this selected twice, once for 20C1, another for 3C1. It was selected twice. Like this, each of these selections had been selected exactly twice. So therefore, we have to have a reduction of a half over here. And therefore, this has to have a reduction of half. I mean, it has to be multiplied by a half. And therefore, this has to be multiplied by a half. And that brings you to 7p value is equal to half as the answer of the second question. This is advanced. This is a question for an entry to an IIT. Make it right, get it right. Stay focused, stay subscribed. Thank you. See you in the next question.